Okay, so last week on, well, not last week, the week before last week, on the Thursday, we went over the 5 types of chemical reactions that we'll be dealing with in Science 10. All right, we need to be able to identify what kind of reaction is going on. We also went over balancing those reactions, okay, and writing them out in words as well. Later on this week, we'll probably get to predicting the products of a chemical reaction, hopefully at some point. All right, so what we're going to do here is we've got 5 examples, and we're going to go over, okay, identifying, balancing, writing out in words. Okay, we'll quickly go over that, and then you guys are going to practice that for a while because this is a skill you absolutely have to be able to do. All right, so first one, I have a chemical compound that is not reacting with anything other than itself. Okay, so it is breaking down into its 2 elements. What kind of reaction does that? Right, simple decomposition. So we would write that this is a decomposition reaction. All right, anytime a single compound breaks down into 2 or more pieces, okay, it's a decomp reaction. Now, I also have to balance this reaction because right now, this reaction says, sorry, you don't have these anywhere. You need to write them down. Just write down number 1 for right now. Okay. Right now, it says that on this side, there are 3 nitrogens, but on the other side, there are only 2. Can that happen? No, because now I don't have the same amount of everything on both sides, and we were told that that for sure has to happen. So if I want to make my nitrogens balance, what's the lowest common multiple of 3 and 2? 6. Yeah, I heard people whispering it. 6. All right, what do I need to multiply 3 by to get 6? 2. All right, so I'm going to put a 2 here, and I'm going to put a 3 there, because that makes 6 nitrogens on both sides. Is everybody okay with that? All right. By putting this 2 here, I also increase the number of oxygen atoms to how many? 4. 2 times 2 is 4. So what do I need to put here? A 2, because 2 times 2 will be 4. And now I've got the same amount of everything on both sides of the arrow. Okay, I've got, remember, this is the reactant side, okay, and this is the product side. Everybody with me there? Okay, remember that when we're balancing, generally we start with the thing that's present in the largest number. All right, that way we can balance kind of that way. Then we have to write this out in words. Now, is this an ionic or a molecular compound? It's molecular. It's got 2 nonmetals in it, right? So that means I need prefixes in the name. So this is trinitrogen dioxide. Okay, and it's breaking down into nitrogen and oxygen. Okay, does the fact that there's twos on those change their names if they're an element? Okay, the answer is no. O2 is not dioxide. Okay, it's oxygen. It's still just O's. Doesn't matter how many there are, it's still O's. Okay, so it's oxygen. All right. Now, for number 2, I want you guys, I'm going to give you a minute, okay? Try number 2. Write it out here first as it appears on the screen. Identify the type, balance it, and write it out in words. I'll give you a couple minutes, then we'll go through it together. Okay? You can refer back to your notes, okay, to see what kind of reaction it is if you need to. You probably will need to for the first little while until you get used to them. All right, let's have a look at number 2 here. So in number 2, I've got an element by itself reacting with, what kind of compound is this? Caroline? It's ionic, okay, so we got an element reacting with an ionic compound to form a new element and a new ionic compound. What's the only reaction type that goes with that pattern? Single replacement. This is a single replacement reaction because the metals are essentially replacing each other here. Right? So it is a single replacement reaction. Now, if I'm going to balance that, the thing present in the largest number is chlorine. All right, there's 3 on this side, 2 on this side. So very much like what we did with nitrogen here, I've got to find the lowest common multiple. All right, lowest common multiple of 3 and 2 is 6. So I got to make sure I've got 6 on both sides. That means multiply this side by 2, 2 times 3 is 6, and multiply this side by 3, 3 times 2 is 6. All right, now what I have to look at is, what else did this 2 I wrote mess up? All right, well, it gave me how many iron? 2. So what needs to go in front of the iron on the product side? 2. Okay, and on this side I wrote a 3 in front of the calcium. That means I need to have 3 in front of the calcium on the reactant side. All right, then we're done balancing. Okay, writing that out in words. Okay, we have calcium plus iron. And is this the iron 3 or iron 2? Because it's multivalent, right? It's got more than one possible charge, so it needs a Roman numeral. Judging from this, I would say it's probably what? 3, iron 3, okay? Every chlorine is -1, and there's 3 of them, so that's 3 negatives. This has to be iron 3, okay? Chloride, okay, gives us iron and calcium chloride. Why don't I write the Roman numeral on the iron when it's by itself? Do elements have charges? They don't. That's why you don't write it. Okay. Iron 3 only has a 3+ charge if it's in a compound. Okay. In this case, it's iron. It's an element. It doesn't have a charge. Okay. It's simply iron. All right. So you never write Roman numerals on elements by themselves. Okay. So starting to ring a bell a little bit. All right. I'm going to give you a few more minutes. Try 3, 4, and 5. Okay. 3 might give you a little bit of trouble because the combustion reactions, I give it away, it's a combustion reaction. Okay, combustion reactions have special rules when it comes to balancing. Okay, you balance them in alphabetical order. And you must also apply, in this case, the second rule, or the rule of 2, as we call it. If there's an even number of carbons, you start balancing with a 2. Okay, the rule of 2 is even number of carbons. You start your balancing with a 2. Right? It's the only way it'll work. Otherwise, you get a decimal, and it'll really mess you up. Okay. All right. So give that one a try. You already know it's a combustion reaction because I gave it away. Something I forgot to tell you: naming. Okay. If you get a hydrocarbon like this one, for naming, I didn't tell you what the prefix for 14 is. Quite frankly, I don't remember what it is myself. Okay, you can just write fuel. Right? Because in a combustion reaction, that's what starts on fire, the fuel. So you can just write fuel for the name. All right, we'll say that that's the rule for all combustion reactions. You'll learn how to name organic stuff in Chem 20 next year if you take that. So, all right, let's look at the balancing for this combustion reaction here. All right, so we said we started out with a 2, okay, on here. So we might as well start doing it alphabetically from there. 2 times 6 is how many? 12. All right, so I need to put a 12 here in front of the carbon dioxide so my carbons balance. 2 times 14 is 28. So I got to go over here. Well, 14 times 2 would be 28. Now my hydrogens balance. Now I need to look at my oxygens. All right, so I've got 12 times 2 is 24 oxygens. So there's 24 here, and there's another 14 there. Everybody follow me? So that's 38 oxygens. Well, last time I checked, 19 times 2 would be 38. Okay, so now that one's balanced. You got to do a little tiny bit of math in your head, okay, but nothing terribly difficult, right, on that one. Now, when we're naming this, again, we said you could write fuel for that, okay, plus oxygen, okay, gives us carbon dioxide because it's molecular, okay, plus water. And you can call it that, okay, that's what it is, right? You don't have to go dihydrogen oxide or hydrogen hydroxide or whatever you want to call it, okay, just call it water. How many people have done number 4? All right, I'll give you a couple minutes on number 4. All right, let's have a look at number 4 here. So on number 4, I've got an element reacting with another element to form an ionic compound. Only one reaction starts that way. What is it? Synthesis. Okay, we're synthesizing a compound from 2 elements. Okay, Now I got to balance. Okay, done. Actually, I'm not done. What's wrong with this? Nobody caught my mistake, hey? Because I put a mistake in there on purpose, but no one caught it. What's my mistake, Tom? Right. This is not swapped and dropped correctly. Okay? Lithium has a +1 charge. Chlorine has a -1 charge. This shouldn't be LiCl2. It should be LiCl. Okay? So there's a mistake right there. Alright, now I do have to balance because now it isn't balanced. There's 2 chlorines here, so what needs to go here? 2. Alright, when I do that, that balances my chlorines but gives me 2 lithium, so what needs to go here? 2. Alright, so now this is balanced. 2 of everything on both sides. Now we got to write it out. Okay, so this is chlorine, okay, plus lithium gives us lithium chloride. Alright, give you a couple minutes to try number 5 there, guys. Alright. What kind of reaction is number 5, where I have 2 ionic compounds reacting? Tom? Double replacement. Alright, so we got a double replacement reaction going on here. Okay, I have to balance. Now, the thing that's present in the largest number is nitrate. Alright, I'm going to balance nitrate as one unit rather than balancing the nitrogen and oxygen separately. They stay together in the same ratio, so I'm just going to treat them like they're an element. Okay, how many nitrates over here? 3. Okay, this 3 here means everything in the brackets there's 3 of. There's 3 nitrates. How many nitrates over here? 2. Alright, again, lowest common multiple of 2 and 3? 6. Alright, so I need to multiply this side by 3 and this side by 2. Alright, now my nitrates balance. That gives me 2 cobalts, so what needs to go here? 2. Alright, and this gives me 3 magnesium, so I need to go over here and make this 3. Now let's just double check because we have not checked what happened with our fluorines on all of that. 3 times 2 is 6. 2 times 3 is 6. Usually if you've done it right, it'll work out that way. The last one you have to do will already be balanced, okay, because you've made everything else work. Everybody with me on that one? Okay, now for the naming, right, they're all ionic. They have to be if it's a replacement reaction. So we have, not a capital, magnesium fluoride, okay, plus cobalt 3 nitrate, okay, gives us magnesium nitrate and cobalt 3 fluoride. Here's the good news about your Roman numerals. Okay, they don't change from one side of a reaction to the other. So if you figure out what it is on the reactant side, it's the same on the product side. Okay, if you started out with cobalt 3, you have to end with cobalt 3. You can't magically turn it into something else. All right, so you wouldn't have to figure it out twice. Okay, questions on how that works? Alright, so I just handed out a sheet to you there, okay, that's got some identification of reactions and some balancing practice. That's what we'll start with, okay? I don't think that sheet's going to take us a particularly long time, right? But I'd be happy to go through any ones that give you trouble on it, and then we'll move on to the next thing. Question? Question? Okay. Yes, the Roman numeral needs to be in brackets. Yeah. Yeah, it did. It just doesn't look like it because my penmanship is so bad. Yeah. Okay, just so you're aware, guys, you can find the keys for this, okay, on my website. Okay, same as you can for anything else. Science 10 notes and assignments. Okay, go into chemistry, and you'll see in here key to reaction worksheets somewhere a little further down here. Keys to all reaction worksheets. If you click on that, okay, the key for all the worksheets is there, so you can check as you go. And you probably have to scroll through a little bit. Come on. Alright, so that's the one you're working on right now. Okay, so if you have your phone out, you can check that one, see how you're doing on it. Okay, and I'm especially going to go over C because C is one of the tougher ones you can run into when you first are starting to balance reactions. All right, our first one here, obviously we got a synthesis reaction. Two elements are reacting to form a compound. Okay, we've got two chlorines on the reactant side, okay, but only one on the product side. So if I put a 2 here, that fixes the chlorine problem, but then I need a 2 here to make my sodiums work. All right. On our second one, we got something breaking down into its two elements. All right. There's 2 mercury on this side, but only 1 over here. Okay. Our other problem is that there's 2 oxygen over here, and only 1 over here. So if I put a 2 here, that'll give me how many mercury? 4. I can put a 4 there, and does that make my oxygen work? Yep. All right, so then that one's done. Now, here's the trick with C. I have to look at both sides of the arrow, not just in individual compounds, to see if I've got elements balanced. Okay? On the the product side of the arrow, I have how many oxygen? 2. On the reactant side of the arrow, how many are there? 3. There's 2 here and another one over here. Everybody follow? Okay, in the dinitrogen monoxide, there's also an oxygen. So there's 3 oxygen on this side and there's 2 over here. What's the lowest common multiple of 2 and 3? 6. All right. I need to get 6 oxygen over here. Okay? Everybody with me there? All right, so if I put, let's say, a 2 here, let's say I double it, okay? It doesn't give me 6, but it gives me at least an even number. Agreed? It gives me an even number of oxygens. So if I look over here now and go, all right, that gives me 2 nitrogens. I've only got 1 over here, so I better put a 2 there. All right, that gives me now 4 oxygens over there, but it gives me how many over here? Does it also give me 4 over here? Yes, it does. Okay, sorry, I shouldn't have mentioned the 6 part because that really threw you off. Okay, so we put a 1 there and we're done. What we have to look at here is what we call the odd-even problem. Okay, it's something that comes up in balancing, especially of synthesis and decomposition reactions. You get what's called the odd-even problem. You have an odd number of something on one side and an even number on the other. Usually, the way to fix that problem is to double the first thing in the reaction. All right, so if you have the odd-even problem, double the first thing in the reaction, which is what I did. I put a 2 in front of this. That makes everything have twice as much, and then after that, it always seems to work out. All right, so if you encounter something like that again, now you have kind of a way to solve it. Okay? All right, keep going there, guys. Give you a few more minutes. Everybody go back to C. I screwed it up. Sorry, I'm just looking at it, and I went too fast, and I made a mistake. Okay? Go back to this one, because I messed it up. Bad, actually. Messed it up kind of bad. All right. When I put this 2 here, that gave me 4 nitrogens. What did I put here? I put a 2 there. That doesn't make any sense. There's how many nitrogens? 4. Should be a 4 there. Okay, for whatever reason, that's what I did. Okay, so now 2 times 1 is 2. Okay, and 4 times 2 is 8. So I've got 8 on this side. I need 6 more oxygens from here. So what do I need to put here? 3. Should be 2, 3, 4. I screwed that up. Okay. It still used the odd-even thing. I just screwed up the rest of them. Okay. So odd-even problem still fixed by putting a 2 in front of the first thing, but I screwed up the rest of them because I couldn't multiply today. Okay. Let's quickly have a look at a few of these other ones here. I want to specifically look at F. How many people are on F? Okay. If you're on F, you probably noticed that on my key, I scribbled out H2O and wrote HOH. Right? Reason I did that is this. It's a lot easier to track where everything goes if you write water as HOH when you have OH on the other side. Because is H2O and HOH still the same thing? Right? It's 2 hydrogens and 1 oxygen. But this way, it's much easier for me to see where the OH ends up at. And as a result, it's easier for me to keep track of how much of everything I have. All right? So what I want to start with in F is the hydrogen. How many hydrogen over here? 2. How many right here? 1. this H has to go with the O. So there's actually only one hydrogen here by itself. All right, so what do I need to write here? If I've only got one free hydrogen, okay, what do I need to write in order to get two of them? A 2. All right, so if I write a 2 here, that gives me two hydrogens, but it also gives me two OHs. So what needs to go here? A 2. How many sodium does that give me? 2. So I go back over here. All right, now everything works. There's two sodiums, two H's, and two OHs. Okay, now everything works. So if you see that, you got H2O on one side and OH and H separated on the other side. Right water is HOH, and it's a little easier to keep track of where everything goes. Okay. All right, let's have a look at D as well here. So single replacement reaction. Okay, best thing to start with is chlorine because it's present in the highest number. There's two chlorines here, but only one here. So I need a 2 there. That gives me two silvers. A 2 there fixes that. Okay, everything else is a 1. All right. Should I write 1s in everywhere where I have a blank? If it's a fill in the blank, yes, write 1s in the blanks. Otherwise, I don't know whether you knew it was a 1 or didn't know how to finish the question and left it blank. Okay, leave no doubt in my mind. Put 1s in the blanks. All right, just to eliminate confusion. Okay, anyone specifically you guys want to go over? All right, keep going. Okay, guys, on J, there should be a space here. I just forgot to put it in. There should be a space in front of H2 on J. Okay, you do need to write a number, so there should be a space. There just isn't one. So cram that number in there if you can. All right, so looking at Q here. Okay, we've got aluminum reacting with hydrogen sulfate. Okay, to give us hydrogen and aluminum sulfate. Right now, it looks like sulfate is present in the largest number. There's a 3 on the product side. So I'm going to start over here by putting a 3 right there. Okay, that's going to give me how many hydrogens? 6. So I also need then a 3 here. How many aluminum over here? 2. So what needs to go in front of this? A 2. Okay, and then this stays as a 1. All right, what kind of reaction is that? Well, I've got an element reacting with an ionic compound, produces a different element with a different ionic compound, so that is a single replacement reaction. R. Okay, so on R, I've got ionic compound reacts with ionic compound, producing two new compounds, so that's a double replacement reaction. Okay, right now, looks like I could use either NH4 or H as my starting point. I'll start with NH4. There's 3 of them over there, and there's only 1 here. Okay, the brackets around it say there's 3 NH4s on this side. There's only 1 NH4 over here, so I'm going to put a 3 there. How many OHs does that give me now? 3. Okay, so if I put a 3 here, okay, that gives me 3 OHs, and it gives me 3 H's. Well, there's 3 H's over here, okay, and there's 1 PO4 on both sides. So now I'm good. 1, 3, 3, 1. Okay. Any others? All right. How many people are done this one? Okay, that's fine. Okay, if you're done that one, you can work on the second one I gave you there. Okay, and the second one, okay, just do exactly what they tell you here. Balance the reaction, write it out in words, and identify the type. Same thing we were doing in the lesson before. All right, so if you're looking at number 1 here, okay, it'll look something like this. You got iron, okay, plus hydrogen chloride. Okay, gives iron 2 chloride plus hydrogen. Okay, and then to balance that out, you need a 2 there, and then everything else is fine as a 1. Okay, and it is a single replacement reaction. So that's what you're doing, okay, for each one on that second sheet. And then when you get to the second side of that, which probably won't happen today, okay, it gives you the reaction in words, and you've got to write it out in formula form, balance, okay, all that good stuff.